Okay, our next talk this morning is going to be on the Steam controller, and it'll be by Eric Hope and John McCaskey from Valve.
Hello. I'm Eric Hope. Today, John McCaskey and I are going to walk you through the Steam controller. We're going to give you a pretty thorough breakdown of how the controller came about, where we're at with beta testing feedback currently, and likely what we're going to ship at volume later this year. We're going to try this again, and we'll resort to this if you guys don't have any questions over the mic. So at the end of this session, if you have any questions, feel free to come up to one of the mics and ask us, and we'll try and get through as many as possible. The first question we should probably get through is why? Why did we go to all the trouble of manufacturing and supporting a custom controller just for Steam? The answer to that question is kind of multifaceted. Over the past couple of years, there's been an increasing number of Steam customers who's been contacting us and asking us to take a look at the living room. Specifically, the reason for this is because many users, the comfort and the fidelity of their living rooms now outstrips that of pretty much every other room in their house. And so they want to be able to play and replay their favorite Steam games from the couch in the living room. The second reason is that there's also a growing number of console generation customers that are coming onto Steam every day. And even though they're excited about the maturity and the robustness of the Steam community, they're still looking for familiar experiences. So specifically, they're looking for appliance-level simplicity around their machines and their operating systems, as well as input device that's super couch-friendly. So kind of with those two intended targets, the customer targets in mind, it was pretty easy for us to start breaking down the bigger problem of a Steam controller into discrete goals. The first and obvious goal was we needed to create a controller that could support play of pretty much every game on Steam, everything in the Steam catalog as it is today, with as little effort as possible expected from our partners, the people who made the games that are on Steam. Our secondary goal was kind of an ideal, something that we would like to achieve if possible, and that was we wanted to embody everything that made Steam and PC gaming in general great inside of a controller. So specifically, we wanted to create a controller that was as extensible and updatable as the rest of Steam. So starting with the initial goal of getting everything on Steam playable by a controller, it was kind of an easy answer. The easy answer was we needed to create a controller that could emulate both a keyboard and a mouse. And the reason for this is because every game on Steam expects and accepts input from a keyboard and a mouse. So even though the answer was easy, we just needed to emulate a keyboard and mouse, going about doing that in a way that was enjoyable for customers was the tricky part of the question. So we decided to start with the hardest half of the two, which was basically how do we get a mouse into a controller? At first, we started experimenting with gyro and motion-based controls, and the precision was somewhat good and somewhat close to mouse-level precision. But over, typical play sessions with lots of different genres, you would get fatigued pretty quickly. And so we quickly realized that motion controls, while interesting for some types of games and some genres, it wasn't necessarily ideal for all games on Steam. So we decided to explore some other technologies. The first technology that we went to was trackballs. Trackballs, they were an obvious target for us because unlike a lot of other input methods, trackballs are one of the few devices that are on a lot of people's desks already. So some people use a keyboard and mouse, and some people use a keyboard and a trackball. Trackballs are great when you bring them into a controller because essentially you take all of the strengths and benefits of mouse input, specifically absolute input, not relative or accelerative input in the vein of analog sticks. Trackballs basically take the surface of a desktop and wrap it into a sphere. So if you can imagine the mouse pad on a typical desk, and you take that and you just wrap it into a sphere, you have essentially an infinite input surface canvas that you can work with inside of the controller, which is great for when you have something that's only underneath your thumbs. Trackballs were also really exciting and interesting to us at first because they have inherent tactility. You can feel the weight of the ball, there's friction, there's momentum, you can throw the ball, and tactile feedback became apparent to us that it was essential in terms of being able to make gross and fine motor movements when you're playing a game. And as good as trackballs were from the get-go, as soon as we started building our prototypes, we quickly realized that they weren't without trade-offs. Some of those trade-offs were that the mechanical and electrical footprints required to support the trackball were very large and very expensive. These footprints actually negatively affected the overall ergonomics and the interior volume that we had available to us inside of the controller. Also, the ideal trackball size, it turned out through lots of testing of different sizes, was very large. This was to minimize the curvature underneath your thumb. And when you have an ideal trackball size that's very large, you end up with a trackball that's also very heavy, which means you also end up with a trackball that is fatiguing in longer play sessions. So with all of those things combined, it made us want to look at some alternate input methods other than trackballs. Really, though, the kind of like Achilles heel of the trackball was the fact that because it was mechanical and because it was an exposed surface to the inside of the controller, dirt, dust, and grime, either from your hands or from your environment, would work itself onto the ball and into the controller, and it would start to gum up the mechanisms. And we were kind of facing a future where customers might have to plunge back into the dark ages of weekly or monthly mouse ball cleanings, and we definitely didn't want to go there. So we branched out to trackpads. Trackpads were another obvious target for us because we had seen trackpads reliably recreate absolute input in the form of a mouse on laptops. And even though we hadn't had any actual good experiences playing games on laptops with trackpads, we still wanted to explore the space as thoroughly as possible for ourselves. So we started building our own trackpads and figuring out what makes existing trackpads bad and what makes existing trackpads good. And slowly, through iteration, we learned that there were a lot of improvements to trackpads over trackballs. One of those was that there were no mechanical moving parts inside of a trackpad, which is great. So we didn't have that trackball dirt and dust and grime problem. We also didn't have all the mechanical infrastructure necessary to support a ball, and so that freed up the internal volume of the controller for us to do other interesting things around electronics and processing. Another interesting aspect of trackpads was that because it's essentially a virtual input surface, we were no longer forced to pick what type of input we wanted for our controller. With a trackball is always a trackball. And when it's always a trackball, you're kind of gated in terms of the types of games that it's ideal for. But with a trackpad, we could virtualize pretty much any type of input surface. So we could virtualize a trackpad, we could virtualize a trackball, we could virtualize an analog stick, we could virtualize a racing wheel. We could do gestural input in the form of like handwriting with your thumb. There's all kinds of interesting software opportunities that made themselves available to a trackpad. And because we're a software company, we love software problems. So then we started this kind of A/B tournament where we were trying to improve the trackpads to the point where they played as good as the trackball. When we first started out with trackpads, they were definitely not as good as a trackball in terms of overall play experience. So we iterated and we iterated. We experimented with different trackpad sizes, different surface textures, different relief patterns to let you know, like to ground you and let you know where you were on the trackpad surface. We even played with the rotation and the orientation of the trackpads to kind of create an ideal situation, an ergonomic situation for your hands. And through all that iteration, with the trade-offs aside, like the manufacturing and the fatigue trade-offs of the trackball put aside, the trackball still had a better overall play experience from the get-go than the trackpad. And so we started looking at this and tried to figure out, why is this the case? The trackpad should be superior because we get to do all these other interesting things with software. The answer invariably ended up being that trackballs, like we mentioned earlier, have tactile feedback, and our trackpad did not. And losing that data channel of information to your thumb based on where you were, how fast you were moving, what the boundaries of the control were, all that was really important information. So we needed to figure out a way to bring haptics and tactile feedback to the trackpad. At first, we started with pager motors. And pager motors are, it's kind of standard fare. Everybody's familiar with a controller that has a motor inside for haptic feedback. Motors kind of give you gross feedback, like they'll give you big swells and kind of smooth undulations of feedback, but they're not very discrete. And we wanted something that could let a user know, like, very discreetly across the surface, have they crossed 1 unit of travel or 10 units of travel? Is there momentum being applied to their finger? What are the boundaries? Are there 4 face buttons inside of this trackpad? And so motors just weren't ideal for us. They were just too mushy. They couldn't be discrete enough for us to solve our goals. So then we started experimenting with linear actuators. Linear actuators are basically electrical pistons. And I can remember the first day that we had a linear actuator hooked up to one of the trackpads. Jeff Bellinghausen, one of the engineers on the hardware team, he hooked it up to one of the existing trackpad prototypes that we had, and we all could hear the linear actuator going. It was like, we're like, what's that? What's going on? So we came over and we held it, and like anybody who held it the first time, they knew that this was a direction worth exploring. Linear actuators, because they're not a motor, because they're a piston, they're much more discrete, and we can get really fine-grained input to the user's thumb. Through testing, we did realize, though, that the linear actuators didn't have enough mass to actually communicate through the PCB and the trackpad sensor and then the trackpad cover. And so then we started exploring force reactors. And force reactors are basically just the bigger brothers of linear actuators. They have more mass and greater frequency response. The frequency response was actually so good with force reactors that we could kind of use the trackpads as little piezo speakers. We could play different sounds through them, and we got really excited about that. And because we were automatically thinking how we could just take straight voice and every voice would sound like GLaDOS from now on. So a couple of prototypes later, we were sold on the trackpad experience. It was definitely as good as the trackball, and it didn't have all of the trade-offs that we mentioned earlier. So at that point, it was just a matter of figuring out the ideal placement of the trackpads, the ideal size, the orientation, the rotation of the trackpads. And we settled on something that was very similar to this. And this solved pretty much our initial goal of how do we get a mouse into a controller. That still left the other half of the problem, which was just as big and daunting for us, which was how do you get a keyboard into a controller? As you can imagine, you probably don't want to take the 100+ keys of a keyboard and just shove them onto a controller. I think some products have tried. We took a look at a lot of the available games on Steam in the different genres and categories. And so even though the keys for those different genres seem to be randomly dispersed across the keyboard, no one game used all the keys at the same time and within the same game. And so that kind of freed up the problem for us. It wasn't so much so that we needed to afford access to every key on the keyboard at all times. It was just sometimes, and that more so that there was a narrow set of sub-keys that we needed to provide access to in a finite amount of space. To solve this problem, we decided to look towards touchscreens. Touchscreens are a great solution for when you have a finite amount of space, but you need to represent n numbers of keys or n numbers of trays of keys. And so we started playing with the placement, the layout, the size, different display types. We're going to do LCD for view angles, OLED. What's the battery draw going to be? What was the processing requirements going to be? And we discovered that touchscreens worked. They did accomplish the goal of when you're holding the controller, you could get from A to Z, to any F keys or numpad keys or directional keys on a keyboard. You could do that. The process was a little tiring and a little inefficient, so we needed to find a way to make that, take the keys that every game required and kind of take the essential keys and bubble them up to the top so that the user didn't have to go A through Z in order to find the one key that they were looking for. Touchscreens were also great because within a finite amount of space, we could bury certain subkeys that you didn't necessarily need all the time. So, for instance, if there's a game that uses the N key on a keyboard for night vision, you don't want the N key bound to the primary buttons of the controller all the time if it's only going to use it twice in the entire game. So we could bury the N key like one or two trays deep inside of the touchscreen. All of this, looking at this from all the different angles, made us realize that we needed a way that we could take all of the bindings of a controller and surface them to customers and let them be able to assign them in the most logical way that they could, which we'll talk about in a second. One other aspect of the touchscreen, and probably the most valuable part of the touchscreen, was that we could communicate information to users through the touchscreen on the controller when they were switched away from their game or from Steam. So specifically, we could let the user know, hey, you have a chat invite incoming, you have a game invite incoming. We could also let them know that the game that you were downloading in the background when you switched away to watch TV, it's downloaded, it's ready for you to play. So that was another interesting angle for the touchscreen. And it actually kind of, over time, began to overshadow the value of the touchscreen when you're playing a game, which we'll talk about now. So in our early testing of using the touchscreen, it was great in the lab on a desk when you're looking at it in terms of getting to the keys that you wanted. But when we actually sat down to play a game, it was not ideal. And the reason for this was because you were shifting your attention from your primary display, your TV, down to the controller in order to hunt and look for whatever the subkey was that you were looking for. And this was kind of frustrating. It broke the feedback loop, and it broke your immersion into the game. So while it was a coarse solution, like it solved the problem, it certainly wasn't optimal. So we started experimenting with adding different tricks to the Steam overlay. Specifically, we wanted to be able to ghost what you were touching on the touchscreen below on top of your screen above. And this was, again, another heavy-handed experiment in order to solve the problem, but it did work. Because the touchscreen was capacitive, we could show where your finger was touching on the touchscreen and then only send the event of what you were touching when you mechanically, physically clicked the touchscreen. And so you could swipe through trays and you could see them show up on the screen above, and then you could see where you were touching on the touchscreen and then send that event. And so this worked actually really well, and we started doing more experiments with that, which we'll talk about in a second. All of this, though, got us to a point where really all we had to solve, all that was left to be solved was the binding problem. And the binding problem is not new to PC gaming. Anybody who's gone out and bought custom PC hardware, you know that when you bring it home, you basically have to set it up. You have to configure it for every single game, either using the configurator that came with the hardware or rebinding your bindings inside of the game. And this is just not ideal. There's been actually really good hardware, peripherals that have come out for the PC that were pretty interesting, but they've kind of died because no one wanted to pay the cost of setting them up for every game that they wanted to play. Especially newer games when they come out and you don't even know what the game expects or what the ideal bindings would be. So we knew that we had to solve this problem. And thankfully, because of Steam, because of the workshop, and because of the overlay, we decided to crowdsource the binding problem. So the default state of the controller at this point is what we call legacy mode. So the controller, when you plug it in with USB, it reports it to the computer as a keyboard and a mouse and a gamepad. What keys it sends and what mouse events that it sends to the game that you're currently playing is determined by the configuration and the binding that's applied by Steam. So in order to make this easy and not intimidating where you have to load like a separate app or like a configurator or a spreadsheet, we created a controller configuration wizard, basically, that's in the Steam overlay. So when you go into Big Picture before you launch a game, you can configure the settings for the game, or when you're in the game, you can bring up the overlay and configure the bindings for the game there. You'll notice that you can bind pretty much anything you want to any physical button on the controller, as well as the virtualized buttons that would be in the touchscreen. Anything that you can want to bind is available. So mouse events, keyboard events, gamepad events, everything can be bound. Everything can also be labeled so that when people come and parse your bindings down the road, they actually understand where you're coming from, where you were going with your binding set. And sharing them is super easy. The default state when you create a custom controller configuration for a game automatically gets shared with everybody on Steam. You have to actually opt out and say, no, I don't want to share this. And whenever someone starts to use your binding set, it gets voted up automatically. When they stop using it, it gets voted down. And that way, very naturally, everybody on Steam, like our passionate customers who care about certain types of games, they're going to create a rock-solid binding set for that game. And that's automatically going to be the default binding set for everybody who goes to play the game, who doesn't necessarily care about configuring a controller or figuring out what's ideal. They just want to be given something. They know that they'll get the unanimously best binding for that game based on all of the contributions through this configuration editor. So with all of that work, it became important to us to be able to make the controller as performant as possible inside of games. If Steam was always sitting there in the middle in order to determine, X button on the Steam controller means F key from the keyboard, the latency was just too high. So we needed a way to bake down the configurations that customers were creating inside of the controller. And so we basically implemented something that we call real-time firmware. And real-time firmware affords us the ability to take whatever configuration that you have at launch of the game, bake it down into the controller, so the controller, those keys, those buttons on the controller actually send those keys, like straight from the firmware, straight from the controller. It's ultra-performant, super low latency. Real-time firmware also becomes really interesting when you integrate the Steam APIs directly into your controller, into your game. So you're hooking the controller into your game loop, because then you can reprogram the controller on the fly. So based on the context of what's going on inside the game. So say you're driving a car and the right pad is a steering wheel. When you get out of the car, you reprogram the controller to now be, a first-person walking, shooting kind of control setup. And we'll talk about that more in a second. But before we do, I wanted to give you a recap of the beta program that we went through. As you know, we released 300 Steam machines and Steam controllers to beta recipients, and we've gotten a ton of feedback. We wanted to do this before anything was close to being called finished, because we knew that if we just shipped what we thought was good or what we thought was best, it would basically be the equivalent of closing our eyes and crossing our fingers and just hoping that when we shipped millions of units that everybody would love that what we had made in our lab. So we wanted to open that process up to our customers because our customers have proven to us time and time again through the Steam community that they can help us shape products to make them better and more palatable to everybody on Steam. Just through the 300 beta testers that have received hardware from us, we've received already over 132 days of combined testing time from them. This would have been really hard for us to replicate. I think Valve's 300 plus employees, so that would have taken every single one of our employees testing every day and night in order to equate this type of coverage. And the types of feedback, the kinds of feedback that we've gotten from our customers have been really, really good. And they're articulate and they're finely nuanced, and almost all of it has been applicable to our development process for the controller. And instead of me giving you a summary of what the highs and lows of the feedback that we've received are, we wanted to bring in a beta recipient today and have you hear his answers to some of the questions that we were asking beta recipients. Chris Kinneber has probably been the most prolific tester of all of our Steam beta recipients. He's made many, many, many YouTube videos of him playing through pretty much every game on Steam OS using a Steam controller and has been giving us really good feedback. So let's have Chris come up, and we'll go ahead and ask him some questions. Hey, Chris.
Hi.
So, how's your experience been with the trackpads?
It's been really good. So the trackpads function in 3 basic ways. You've got a mouse emulation. You've got 4 or 8 buttons that you can press with it, and then you also have a physical button that it presses down with. So as a mouse, I was kind of skeptical, but it feels really good. The haptic feedback was something that I wasn't expecting to work nearly as well as it does, but very quickly I was able to move around in a first-person shooter fairly naturally, moving around with a cursor to the point where I'm feeling fairly confident playing StarCraft versus a hard AI without any hotkeys, because the bindings problem does become a little bit of an issue there.
Yep. So what's your experience been with the legacy mode, specifically emulating a keyboard and mouse instead of the direct support inside of games?
Sure. The legacy mode, it's difficult in some games and amazing in others. In a game where you have limited number of keys, some certain platformers, that feels really good. Some platformers have a little bit of an issue with essentially not being able to map that A, B, X, Y configuration that you're used to. You end up with the trackpad tapping down in the wrong place or not noticing when you're tapping. So there's some issues there, but for the most part, I felt pretty good until I hit something where a user interface prompt from the game shows me something that I'm not used to. So left mouse click. When I'm doing that, it's going to have a left mouse button or something like that. And I'm going to have to hit the right trigger because that's what feels good on a controller. But that kind of cognitive dissonance is difficult. And you also get that in something where I have to press F or G in Metro Last Light. I don't know where G is bound, and there's no really easy way for me to know, so that can become kind of an issue.
That makes sense. So what are you looking forward to most in the coming months of development and integration from our partners?
Sure. I'm really interested in just how you guys iterate with the controller. I'm interested in seeing gameplay that's made more specifically for the controller. I think that there are really interesting things that you could do with a trackpad. Also just getting away from legacy mode in the future and getting towards more direct input.
Great. Thanks, Chris.
Thank you so much.
Thanks. So like I said, we've already been incorporating all of the beta feedback that we've received from our beta testers so far. And we've received a lot, and it's been really good. And I wanted to take this time now to walk you through some of the changes that are coming to the controller that most likely will ship at volume later this year. So the first thing, as you'll notice, is there's no longer a touchscreen. The reason for this was because the touchscreen, when we first started experimenting with ghost mode, kind of became irrelevant. As soon as we could ghost what you were touching on the surface of the middle of the controller, on top of the screen, on top of the game, while you were touching it, we really didn't need a touchscreen anymore. The touchscreen really was only valuable when you were outside of Steam or outside of a game, and you were just kind of looking for updates. And it was kind of weird for us for the controller's most expensive component and infrastructure to be the least frequently used feature of the controller. And so in an effort to reduce the total cost of the version 1 Steam controller, we decided to take the screen out and put a touchpad in the middle of the controller instead. As soon as we had a touchpad prototype where it was in the middle of the controller, one of our smarter engineers realized, hey, we actually have 2 trackpads on the controller already, and they're already underneath your thumbs, so we don't really need that area in the middle anymore. So we took that away entirely. And as soon as we started experimenting with mode shifting the existing trackpads into this catch-all virtualized keyboard area, it actually tested really, really well. For instance, some of the improvements over the center touch area was the center touch area, though it was in the middle of the controller, you could really only comfortably hit half of it with each hand without unanchoring the rest of your hand away from the controller. So that meant you had to kind of be strategic about, when I assign something to the top left quadrant, what do I want that to be? And when I assign it to the bottom left, or the top right quadrant, what do I want it to be? And the bottom left, what do I want it to be? With the circular trackpads, you actually didn't need to use both hands anymore. We could mode shift, using the paddles on the back of the controller, we could mode shift one of the pads to be any number of slices, and those slices could keep going. So you could imagine rapidly scrolling through all 100 keys on the keyboard if you really needed to, or you could go 4, 8, 16 different slices at a time. So this, in testing, was a superior solution, and by yanking the touchscreen out of the middle of the controller, it actually reduced the cost of the controller significantly, which we thought was a total positive. One of the other things that we've gotten a lot of feedback through the beta process was about our quote-unquote face buttons. So it was kind of an interesting decision. We labeled these buttons A, B, X, and Y, kind of in an effort to be able to equate legacy naming conventions of control so that when games in legacy mode would throw up those traditional names of buttons to press, there was kind of an anchoring point, like physically with the hardware. You could start to memorize A is here, B is here, X is here, Y is here, etc. But we got a lot of feedback from customers that, when you split these two buttons across the controller, it's not optimal because my brain doesn't want to cognitively split half of the face button input across my one hand and then the other half across the other hand. And we realized that, and we understood that from the beginning. And one of the reasons why we had even had these buttons here was because we had 4 discrete physical buttons on each side of the controller without taking your thumbs off the pads. The pads click, the bumpers click, the triggers click, and the paddles on the back click. But because they were never labeled A, B, and X, and Y, it was really hard for people to kind of map those traditional behaviors and associations onto those buttons. And so the quadded A, B, and X, Y buttons were kind of a hang-up for customers. And there was legitimate feedback that certain types of games, like certain genres of fighting games and platforming games, it was actually an inferior experience to have these buttons split across. So in addressing that feedback, we're bringing button diamonds to the Steam controller. Already in our internal testing, this is a remarkably better experience. Basically, we get to keep all the improvements that we brought to the Steam controller, specifically the virtualized trackpads, the paddles on the back, the improved ergonomics. But we also get to basically backward support every game that's on Steam that already has a notion of what a direct input or X input controller might be. And since we had already taken the screen out, we no longer really needed the lithium battery rechargeable pack inside of the controller. And since that was the second most expensive component in the controller, and it was serving that need that was, like 10% of the usage time, we decided to take the rechargeable pack out for the version 1 Steam controller. Now we just use straight AA batteries. So the rechargeable decision kind of ends up being a user-level decision. If they want to recharge AA batteries, they can, or they can just use standard batteries. So those are kind of the changes that are inside of our internal prototypes currently. And with that said, we do want to re-emphasize to you, our partners, that whatever we ship at volume later this year, it's going to be a stable base, a stable foundation for you to target and integrate into your games. And so even though we may add features down the road, like we may bring a touchscreen back because it is interesting some of the time, and we may bring rechargeable batteries back, and we may add other premium features that our customers ask for, we're not going to fundamentally change what the controller does today. So what we ship later this year will be a stable base for you. A good example of that is the controllers that you received today. They're the remaining units that came off our first run of the assembly line when we were testing our experience of how do we manufacture controllers. The first 300 went to beta recipients, and the rest have gone to you guys today. These controllers, even though they're slightly different than what I've just described as what we'll ship later this year, they're still fundamentally equivalent. So it's the same number of buttons. The placement and the orientation of the buttons has only changed. So what now? Well, we need your help. You heard Chris talk about kind of the joys and the pain points of legacy mode. And legacy mode was simply just a stopgap solution for us to be able to support controllers through the entirety of the Steam catalog. But it's not an ideal solution. So with regard to legacy mode, if you can take the controllers that we're giving you today, and for all of your games that may not necessarily be in active development, if you can create a really good legacy binding for us and then submit it to us, we'll make sure that that's the default binding for every customer that goes to play the game with the controller. And then they could decide if they wanted to choose something else from the community later on if they'd like. But if you are still actively developing some of your games, we really want you to implement the Steam controller APIs into your game. As soon as you start talking to the Steam controller in real time, you can start doing some really interesting things. I kind of alluded to some of the little experiments that we had been doing internally, but it's kind of the sky the limit. It's like whatever you want to program, you can do on the controller now, and you can change that behavior based on what's going on inside of your games. To walk you through just how easy it is to incorporate the Steam controller API into your game, I'm going to have John McCaskey come up. He's basically the father of the Steam controller API.
Thanks, Eric. Okay, so as Eric said, I'm John McCaskey, and I'm going to walk you through a little bit of what it takes to get native controller support into your games, which will hopefully address some of the issues that Chris was talking about around the cognitive dissonance of having incorrect mapping shown in the game and things like that. So we hope that this talk will be pretty brief, but the controller API is very simple. So at the end of the talk, you should have a clear idea of the scope of work and what it would take to get native support into your game. And since you're also getting controllers at the event, we hope a lot of you will be excited to go back and get started on working on that integration right away. Okay, so the first thing you need to know about the controller API is that it looks a lot like the existing APIs in Steam. You call Steam controller, that's the name of the interface, it's iSteam controller, and then you call a method name to make calls. Unlike some of the other APIs, though, this API is a little bit different in its internal plumbing, and it's not going to be making cross-process calls to Steam in a blocking way each time you make an API call. There are a couple calls that will, like init, but the common calls that you're going to call frequently are actually non-blocking and very fast. So as we go through, you'll see, oh, I'm going to have to call some of these multiple times per frame. You should just know that that's going to be okay, and it's going to be very quick. So for the init call, you're going to call Steam controller init and a path to a config file. Now, we're not going to go through the config file in a ton of depth during this talk, but essentially it's a human-readable config file, and it defines sort of our legacy mapping support primarily. So when you're implementing native support, you won't always need to use all those features. A lot of the time, your config file might be mostly empty and just say the keys are unbound. But there will be some times when it's useful to mix a little bit of the legacy keyboard and mouse binding mappings with native support, which we'll talk about a little bit later in the talk. Okay, so once you've initialized successfully, what you're going to want to do is basically get the state of each controller, each frame in your game, and fire whatever game input events you need to handle. So that's going to look pretty simple. You have a Steam controller state struct. I haven't outlined the exact members of the struct here on the slide, but there's basically going to be a sequence number. There's going to be left pad coordinates, right pad coordinates, and there's going to be a bit field for buttons. The buttons bit field, in addition to the up-down state of all the individual discrete digital buttons, is also going to have things like, is the user's thumb currently touching the touchpad for both the left and the right pads? So you're going to basically iterate through each frame in your game, probably between 0 and max Steam controllers, and you're going to call get controller state. If this call returns false, then it simply means there's no controller connected at that index right now. Go ahead and move on. If it returns true, then it means there is a controller connected at that index, and you're going to have the state of that controller filled into the struct. So then inside that if call, your game would do whatever it does with input. This hopefully looks really similar to some other APIs you've seen before. If your engine already has something like X input support in place, our hope is that you'll be able to drop this in really easily and just start firing off input events in your game. So the next thing that you're going to do as soon as you get basic button firing working in your game is you're probably going to want to implement haptic feedback. For our controller, this is really important. When you implement, say, a 360 controller into your game, sometimes developers skip force feedback in that case, and they just get the buttons working. And that actually works pretty decently a lot of the time, because users aren't accustomed to constant force feedback necessarily, and the buttons have a good clicking motion and feel really solid. For us, when you're using the touchpads, as Eric alluded to in his talk, it really just doesn't feel right if you're not getting that sort of feedback from the device about the motion that you're doing on the pad itself. So in order to implement haptic feedback, you're going to call Steam controller trigger haptic pulse. You give it a controller index, so this is going to match up with whatever index from get controller state that you've assigned this user to. You're going to give it an enum value that's going to be left or right pad, and you're going to give it a microsecond duration. So the duration is basically going to map to the perceived amount of feedback that the user gets. A shorter value is going to feel like really light feedback, not very strong, and a longer value is going to feel like a much more substantial pulse of feedback. So, if the user's getting shot and hurt in game or something, maybe you're going to use a large value. If they're doing really fine motion, you might use a small value. So, as the slide says, good values start around 100 and go to around 2,000, but you really just want to experiment in game and try whatever values. The other thing that you'll want to do with this API is determine how frequently to call it, because each of these calls is just going to be one pulse of feedback. When you start using the controllers that you've got now, you'll notice when we're doing things like mouse and motion movement, we sort of pulse it at a variable rate. So we keep track of the user's thumb velocity, and then we'll call it more frequently. You could go ahead and call this call every single frame in your game if you wanted to. You probably won't want to get quite that frequent, but you'll want to play with the frequency and the values to get the right sort of feel for the user. Okay, so that's actually pretty much it. We've covered all of the basics you need for native support. There is one other advanced feature that I want to cover today, which is called set override mode. Set override mode is basically what I alluded to earlier with the config file, and it lets you sort of combine legacy support with native support in your game. So you're just going to pass a string to it, and that's going to map to a section in the config file that basically says, when I'm in this mode, don't use the default bindings I defined for all the buttons, but instead use these that I've put in this override section. And you're going to use that for things like, say you have a legacy game that you've already shipped and you want to support our controller better, but you have a menu system that's really been designed around the mouse. And it's a pretty substantial amount of work to change it to be sort of D-pad directional movement, like many users would expect with the controller. You might decide that, okay, well, we're going to punt on actually changing the menu system in that way, but we're going to go ahead and make gameplay really awesome with the Steam controller. So in that case, you'd set up your default config to have nothing bound. You'd use get controller state. And in gameplay, you'd have really good native support. When you go to the menus, you just go ahead and call set override mode mouse. And what would happen is in your config file, you would have said, for mouse override mode, map the right pad to a mouse, map some of the buttons to mouse buttons. And that will actually work pretty surprisingly well for a lot of games that have mouse-based UI. You don't have to remember all those details I just talked through. There's a detailed example of this in the Steamworks SDK. And by the way, the Steamworks SDK, the current version of it on our partner site, already has the API in place. So as soon as you get back to work, if you want to check it out, it's all there. You just need to pick up the latest drop. And there's documentation on the site as well that's going to cover most of what I'm talking about today, as well as the details of the config file format. Okay. So we'll talk a little bit about the future of the API. Eric already kind of alluded to this as well, but we're really trying to make sure that what we give you guys today and ask you to go implement for isn't going to change in a way that's incompatible or where the work that you do now is not going to be valuable down the line. So we want to assure you that that's a big priority for us, and we're going to make the API. It's probably going to expand as we get feedback from you and from users. We might add more features. We might do stuff where we take care of some of the we help you with velocity calculations and haptic feedback more and have some defined patterns for that. But if you've implemented the get controller state and you've done the basic haptic feedback, that's going to continue to work. And as I said before, a big goal here is that the surface area of the API is really small and simple. We want it to be as easy as possible for you. And we'd love to hear from you about any questions, any ideas for improvements. So you can come talk to us after this talk. And we're also going to take questions now.
Okay, so we're going to try and use the Twitter feed first, and we'll see how that goes. And then if we need to, we'll swap back to the microphones. So let's get this over here. That's the wrong account, by the way. Oh, I didn't hit anything. Okay. John, this looks like this is for you. Does the API allow developers to catch controller bindings to set up proper UI feedback / tooltips?
We don't actually have an API for that right now, so if your game's been set up where it's in a legacy mappings mode and you haven't implemented native support, we don't have a way to say what are the legacy bindings and just show the right UI. I think our preference is for you to sort of implement the native support, and you'll probably get a better, clean experience then. If there's a reason why that's difficult, you should talk to us, and we could give you an API that would tell you what strings to show just for bindings in game.
How customizable is actually controller hardware? Can it be turned into a physical string? I don't. Okay. Thanks. Yeah, those were automatically progressing. Sorry for if you saw yours and got excited and it's gone now. I apologize. Will a distinct binding be set up for the left-handed users, or will they need to manually find it every time? So we've put some thought into this. Currently, we're trying to figure out what the ideal solution is. So because the controller's symmetrical, handedness can kind of just be a flag that you set, and you just flip all the bindings. We don't actually know if in practice that this is the ideal thing for customers, if this is what customers will expect. So this is kind of to be defined. We still have some experiments to do and some beta tests to run through first. When do you plan to integrate biometrics into the Steam controller? Speaking of landmines. So the Steam controller, we did do extensive experimentation around biometric feedback, capturing that feedback inside of the controller. It turns out that your hands are not a really great place to acquire that information because your hands are constantly moving, your sweat level varies over time, how you change your grip, all that stuff affects the quality of the signal versus noise ratio that you're getting out of the controller. We still believe that biometric feedback is super important, but we just don't think that the hands are the right place to capture that. So I guess the answer to that, the vague answer to that, is more on that soon with maybe some other products that we're currently exploring. I'll try and circle back and get any of the earlier ones. Will the controller work with Windows, Mac, and other platforms? Is this left to the open source community to develop drivers? John?
It will work with all those platforms, and it's not left to the open source community. We've actually already done it. The way the controller works is it uses a generic HID USB endpoint, so it doesn't actually need a driver installed. It just uses those generic endpoints that are already installed on all machines. So there's more technical detail there, but the main point is it's just going to work.
Thanks. Can the right trackpad mimic analog movement, and so you don't have to continually swipe and turn like on a trackpad? Yes. Initially, that was one of our primary goals for trackpads. We needed to be able to replicate that type of movement. In fact, the left trackpad is typically ideal for a virtual analog stick because when you're moving, like walking around inside of games, that actually feels really good. Most PC games, however, are very digital, right? Like it's WASD, and so you're like tapping at interval rates or you're holding the key down. And so direct integration of the Steam controller where you actually do a virtual analog stick is ideal, and it can be done. I think we covered that.
Yep.
Yeah, let's see if there's anything else. Would we be open to allowing third-party hardware developers to make controllers that utilize, I'm guessing that's like physical analog sticks instead of trackpads? They totally could. It wouldn't quite be a Steam controller at that point. There's going to be a lot of games that are going to depend on the programmability of the trackpads. And as soon as you took that out of the controller, it would probably get really messy for customers in order to predict how that controller would behave for different types of games. And it looks like that's all we have on Twitter. I think we have like 5 more minutes. We could probably take some microphone questions. So
if you got your hand up, we have some microphone volunteers here. So let's just take the microphones over to people. And as soon as you have one, I'll point at you.
Just a question about ergonomics. How much testing have you done on these? I mean, I might just be an idiot here, but I feel like the paddle's a little sharp against my finger. Am I the only one? Have you working on that, ergonomics?
So you're not an idiot. We've done extensive testing. We've spent a lot of time on ergonomics. What you're holding today is not the definitive representation of that testing and iteration. You will find legitimate pain points on the controller prototypes you have today, and the reason for that is because we shipped before we were even close to being finished. Like, we shipped these prototypes to you guys before we were close to being finished. So any feedback that you have around, like, this hurts somewhere, please send that to us. Don't assume that someone has already captured that feedback. We want everything. We have good tools to parse through all that and make sure it gets addressed. Specifically what you're referring to, we just recently had some new 3D printouts a week ago that is addressing that. So that's awesome. Oh, sorry.
I know you guys are doing the standard controller right now, but you guys plan on doing a Cadillac version at different price points, LCD if you really wanted it, stuff like that?
Yeah, we would love to. We don't know for sure if we will, like with certainty, but we know we would love to iterate and would explore different premium features that our customers ask for. Really, our goal for the version 1 Steam controller was how can we make a controller that is as palatable to as many Steam customers from day one at a minimal cost to basically experimenting with this. Because it's very different. You'll notice when you're using the prototype controllers that it's a whole nother thing, and it takes a little while to get used to. But we're really excited that once you've spent maybe half an hour or an hour with the controller, you kind of start to question, what does it mean to play games from the couch?
Okay, over there.
I've just got a question. Are you going to put the triggers and making them analog or not? Because like for racing games, you want to have acceleration and brake. You might want to cross-use them at the same time, and you can't really do that with an analog stick or the touchpad.
Yeah, so we are currently experimenting with analog triggers. The reason why the prototypes that you have today are digital is because most games on Steam currently they expect digital input. It's a mouse click, right? But there are totally types of games that benefit from analog, and we don't want to necessarily exclude any type of game or genre, and so we're currently exploring that space. We want to be able to do an analog trigger that is good for everybody, and so it could be discrete, but also provide that range of information to the controller. So we're definitely exploring it, and it's a goal. I can't, confirm for sure that it will be in the version 1 shipping controller, but it's something we're working on currently.
Hi there. Hey guys. Sorry. I just had a question about VR integration. Are you guys planning on creating a controller that will take advantage of things like motion controls when it comes to integrating with things like the Oculus Rift and VR in general?
Yeah, so one of the drivers behind us making a controller was actually VR. Anytime you put on a VR headset and you try to find your keyboard and mouse on the desktop, it's not ideal. And having something that's anchored in your hands is actually really good. So with that said, you're specifically referring to motion-based input. The prototypes that you have today do have gyros in them. They're not turned on in software yet, like you can't access them, but it is in the hardware. One of our goals for the shipping controller is to have some kind of gyro inside of the controller so that we can do motion-based input to some degree. We've noticed just by having a gyro for like racing games, it's fantastic. If the gyro is of a high enough quality, you can get some really good experiences out of it.
Okay, way over there.
Yeah, way over here. Have you guys done any testing that gives you insight into whether or not someone using a Steam controller can keep up with a player using a keyboard and mouse in, say, a competitive gaming setting like Counter-Strike?
It totally depends on the game. Regarding Counter-Strike, I don't think anybody has spent enough time with the controller for it to be a fair comparison. Like, we haven't had the 12-year-old who spends 90 days with the controller, 24 hours a day, to go up against the world's best mouse Counter-Strike player. With that said, we have had very close, comparable test scores, like going through the CSGO obstacle course, the training course. We've had very close time scores through that mode. So we think it's possible. I wouldn't say that it's guaranteed or that it'll be normative for everyone to be as good, but it certainly, after practice, the controller kind of disappears and you stop thinking, I'm using a controller, I wish I was using a mouse. But it definitely takes time, and it also depends on the genre.
Hello?
Hey. Okay.
Have you worked at all with Unity 3D to see if the controller API and the controller is supported inside Unity?
John?
Sorry, I didn't catch all of that. Can
Unity
you ask again?
3D.
Oh, what?
Have we experimented with Unity 3D in the controller at all yet? For integration?
We haven't explicitly been experimenting with Unity 3D ourselves. We definitely, a lot of games are shipping on Unity and we want it to be well supported. A lot of times with Unity, we've relied on sort of third-party plugins to get a lot of the Steamworks integration done for other developers. So that might be an approach that we take there. if you're using Unity and you're interested in working on that at all or getting the API integrated, you should reach out to your Steamworks tech contacts, and they can put you in touch with me, and we can talk through the details.
I'll let you pick. We'll take 3 more questions. That way you guys can have a little break before lunch.
How many simultaneous controllers do you support?
It's 16 right now.
Awesome.
Which should be enough for the moment.
And iOS support. For
Sorry,
Steam
can you
controller.
repeat that?
What about Android and iOS support for Steam controller?
iOS support.
Android and iOS support. We don't have any Android or iOS support that we're currently testing or explicitly developing. Because it's just a generic USB HID endpoint, it really comes down to whether a device is going to support USB HID endpoints. So I think the answer to that is that it could be done.
Yeah.
And if you have a use case for that that's valuable to you, you should reach out to us about the details there.
Okay, one more.
Yeah, during the API section, it seemed to suggest that each game developer would set up their own feedback for what it meant to press a button. Is there a plan to have like a default set of values that can be used so like across games what a button click feels like on an analog or on the trackpad feels the same, or even allow me to set like I want less impact as a user?
Right now, the plan is that we're going to let developers control that when they do native API integration. So when games ship without native API integration and we have the legacy support, there is sort of a default set of what we've said mouse movement should feel like and what like left pad WASD emulation should feel like. So expect that we've tweaked those values a bunch and feel like they're good. So we expect that you guys, when you go to add native support for your games, will probably end up doing something similar and sort of emulating that. And that's an area where we really want to hear from you. Like, if you're finding that it's difficult to get the right values there, then we want to provide more defaults there and more support there. But we also want to give you full freedom. And because we don't feel like we've completely explored the problem space and figured out the ideal input for all types of games, we want you to definitely have the freedom to experiment there and try what you want.
Great. Thanks, everybody. I think Chet's going to come up with some announcements.